Oh, here's 2026 AB Calculus, problem number 5. I haven't looked at this at all. Let's see what it says. A remote controlled toy car moves back and forth along a straight path. Great. So that its velocity and time is given. Okay. Um, and it looks like it gives you that little piecewise function and the graph as well. Okay, find the acceleration of the car at time t equals 1 second. Show the work that leads to your answer. So we're looking at velocity, but we need acceleration. So this is, I would just look at, well, you can look at the graph and right here and tell that it's going to be positive right there. However, we have access to, give a pen, a different color. We have access to the equation right here, so might as well just use that. So for part A, the acceleration would be the derivative of velocity. Okay, so that's 4t cubed minus 24t squared plus 32t plus 32t, right? Check the math there. 4t cubed, that's 24t squared, yes, plus 32t. Okay, and we're going to simply find a sub 1, or a of 1, I should say. This is going to be 4 minus 24 plus 32, and that'll be 12. But be careful of your units, feet per second squared. Feet per second squared. That would be your area. And again, you can see that it's positive right there, that slope. But you just find the derivative with that piece, of course, being the first piece because 1 is between 0 and 4. Okay, so not much to say about that. Okay, what's next? It says for part B, is the car speeding up or slowing down? This goes back to your just your straight up knowledge. We are speeding up. I'm just going to write this out. Speeding up if A and V have the same sign. You just have to know that. How do you know that? Well, you just got to study. Really know your triggers for this. You're slowing down otherwise. Okay. If A of T and V of T are opposite signs. So writing out your facts, I think, is helpful because I can earn some points potentially. So at time t equals 1, we've already figured out that the acceleration, that 1 was 12. That's what part A was for. So we got that. We just need V of 1. Okay, well, V of 1, you've got V right there. You know it's positive, but you can't tell on the graph. So V of 1 is just going to be 1 minus 8 plus 16. That is 9 feet per second, if I'm doing my math correctly. So this is speeding up. Okay, because, again, we've explained it, right? Give a reason what we did. And there you go. Part C, find the distance in feet that the car traveled from 0 to 4. Distance in feet. Okay. So to do this, I'm going to clear off the red here. So I'm going to need some space. Total distance is the integral. This now total distance versus total displacement. Remember, that is the absolute value. However, because I can physically see that that is positive, the absolute value is just not necessary. So I'm going from 0 to 4. So this is, again, I'm just keep using the same thing. T to the 4th minus 8t to the 3rd plus 16t squared dt. Those t's are like pluses. Be careful. I'm evaluating from 0 to 4. So this is t to the 5th over 5. Oh my goodness, this is going to be a big number. Minus, what is that? We got to go t to the 4th. So that'd just be 2t to the 4th, wouldn't it? 8 divided by 4. And this is going to be, I got to go t to the 3rd, 16t to the 3rd over 3. I'm going to evaluate that from 4 to 0. My goodness, the arithmetic. So when I plug 4 in there, 4 to the 5th, that is 1,024. Pretty sure. Same thing as 2 to the 10th. And then 4 to the 4th plus 16. My goodness. 4 to the 3rd. They must really like y'all to show your arithmetic prowess. 4/5 is 1,024 divided by 5 minus 2 times 4 to the 4th. Gosh, 4 to the 4th is 256. So I'm pretty sure that's 512. Let's say 4 squared is 16. 256 times 2 is 512. And good, great. 64 times 16. Come to the side here. 4, 2, getting the old school here, carrying the, so 4, 2, 1, 4,024 again. How about that? 1,024 over 3. I hope this arithmetic is correct. Well, I need a 15, don't I? Man, this is nuts. I can multiply, let's see, this by 5 isn't terrible. So that would be 5120, right? 24 times 5 is 120. And then add that to 5,000. Oh my gosh, 512 times 15. I should have gave you a smaller number here. This is aggravating. 086, so 7680. And then multiply that by 3. That's not bad. 3,072. And then subtract that mess. Was that a minus right there? You go back. It's minus. I just hope my arithmetic's correct. I don't know why that thing does that. It disappears when I go back and forth. But as it is, I'm going to add these two. 5120. Add that up. 291, 8192. Subtract 7680. 2, 1, 5. So 512 over 15. Yeah, I hope the arithmetic is correct. Anyway, I'm making this video. I can go back and check it, but I'm just going to hope at this point, I'm just going to hope that's correct. 512 over 5. And we're doing, what do you even ask? Total distance. That would be that many feet, right? That many feet. Yuck. 100 and you can work that out. It'd be what, 102.4. If I did my math correct. I'm gonna go on to the next one. If it's wrong, just tell me. I hope that's right, but at least you know how to do it. The average velocity of the car over the time. Find the average velocity from 6 to 12. Show the work that leads to your answer. Average velocity. Okay. So one thing that's easy to confuse if you're not careful is average rate of change versus average value of a function. Was asking for the average velocity, and that is what I have access to right here. So for the first time, we're actually going to use this part here. So we would do the average value of the function, right? Because we have access to the velocity. So that's going to be 1 divided by 6 minus 12. So that's 1/6 from 6 to 12 for this function 10 cosine pi over 3 t minus 10 dt. So I got to find this, you got to take the antiderivative of that. All right, so the first thing I'm going to do is kind of factor out a 10. Would y'all be, so I'm going to put a 10 out here. So 10/6 from 6 to 12. And now we have a cosine of pi over 3t minus 1 dt. Get rid of that 10. Okay, so now we're going to take the antiderivative. Okay, so that simplifies to 5/3. But we got to do a u sub here, don't we? So let's do that. Different color. So if we let u be pi over 3t, then the derivative of u with respect to t is pi over 3, which in turn means that du is pi over 3 dt, which in turn means that dp is the same thing as 3 over pi, right, du. So I'm going to change, you hold off on my limits here. This is going to become the cosine of u now, minus 1. And dt is now 3 over pi du, according to that. Okay, so I'm going to get the 3 over pi and just put that on the outside as well. So if I do that, wouldn't it become 5 over pi? Just make sure. 5 over 3 times 3 over pi. Yeah, so those cancel. This is now 5 over pi. I didn't forget about my limits, so we just got to fix them. Of cosine u minus 1 du. Okay. Now, what are my limits? They were 6 and 12. If I go back, we let u be pi over 3, didn't we? Pi over 3 t, was that what it was? Let's look back. Yeah. So u is pi over 3t. But if t is 6, which was the bottom limit, is pi over 3 times 6. That's 2 pi, isn't it? That's going to be my new one here. And if it's 12, pi over 3 times 12, that's 4 pi. Okay, so that way I don't have to go back. I'll just leave the u. So now I've got 5 over pi. The antiderivative of cosine is sine, right? The derivative of sine is cosine. So we got sine of u, and we're now in u world, so minus u. And we're going to evaluate that at 4 pi and 2 pi. All right. So that's going to be more room. 5 over pi times, let's put 4 pi in there. So it's the sine of 4 pi minus 4 pi minus the sine of 2 pi minus 2 pi. Okay, so 5 pi. Now, what is the sine of 4 pi? Well, 4 pi is just going to be right there where, right there, right? All right, where so is 2 pi. They're both, and the y coordinate on both of those is 0. So that's nice. So it becomes 0 minus 4 pi minus 0 minus 2 pi. Blah, 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 blah. Let's see. Let's keep on going. Now I got 5 over pi. All right, so this is going to be negative 4 pi plus 2 pi. All right? Negatives. This is 5 pi times negative 5 over pi, excuse me, times negative 2 pi. Pi's cancel, so I'm getting negative 10 after all that. I don't even remember what an was asking. That's the average velocity, right? So the feet per second. Let's make sure that looks right. I about used my 15 minutes, haven't I? Average velocity over that interval. Okay, yes, what's negative? Your velocity is negative the whole time. Back on here, so that would make sense that it would be negative. So that's my story. I'm sticking to it. If y'all see a mistake, let me know. I'll fix it. But that looks, I hope that's right.